morning, everyone. Myself, Dr. Jugal Kishore Mahant from Department of Applied Biology, University of Science and Technology, Meghalaya. This presentation or e-content development program, and today I am presenting one of my chapter, of the course curriculum of bachelor's degree in biotechnology, and specifically the paper is environmental biotechnology, and module is Acidophiles, that's Acidophiles. And this presentation or this video presentation development is a part of evaluation in the faculty development program conducted by Teaching Learning Center, Tajpur University, and I am presenting one of my module here as a evaluation process, and I am going to discuss about the acidophiles, and these are the some of the extremophiles which are generally found in extreme environments and highly acidic environments, and most of these organisms are belongs to microorganisms. What are the meaning of acidophiles? pH values less than 7 are said to be acidic, and the microorganisms that have their growth optimum between pH 0 and pH 5.5 are called acidophiles. Fungi as a group tend to be more acid tolerant than bacteria, and many of them grow optimally at pH 5 or below, while a few grow well at pH value as low as 2. Many numbers of bacteria are also acidophilic. Some of them are obligate acidophiles, unable to grow at pH 7, which is known as the neutral pH. But this species includes of Acidophiles and Leptospirillum and several genera of archaebacteria such as Ferroplasm, Picrophilus, and Thermoplasma. And this Thermoplasma, Ferroplasma, and Picrophilus are the archaebacteria among the most acidophilic of all known microorganisms. And Microphilus is capable of growth below pH 0. Thermoplasma apparently metabolize organic compounds leached from the hot coal refuge. Thermoplasma volcanium has been isolated in hot acidic soils throughout the world and is highly motile by multiple flagella. Ferroplasma is a chemolithotropic relative of thermoplasma. It oxidizes ferrous to ferric to obtain energy, and during this process the acid is generated. Ferroplasma thrives in mined tailings containing pyrites, ferrous sulfate pyrites, which is its energy source. The extremum acidophilia of ferroplasma allows it to drive down the pH of its habitat to extremely acidic values. Picrophilus is even more acidophilic than thermoplasma and ferroplasma as it grows optimally at pH 0.7 and is capable of growth to as low as pH 0.6. These two species of Picrophilus have been isolated from acidic sulfates in Japan. And this is the basic and very important to know that how these microorganisms are able to grow in such a extreme and very low pH condition, and there must be some molecular mechanism is there, molecular metabolism is there, by which they are able to adapt such environments and go for reproduce and increase their number of populations and sustain their genome system, cytoplasmic system, everything they have to maintain through these molecular adaptations. So we should know some molecular adaptations to acidophiles. The critical factor that governs acidophile is the stability of the cytoplasmic membrane, most important, because most of the stability and of the cell depends on the cytoplasmic membrane only, because most of the transportation, signaling, everything is highly dependent upon the structure and stability of the membrane. When the pH reaches neutrality, that is pH 7, the cytoplasmic membranes of strongly acidophilic bacteria are destroyed and the cells lyse. This indicates that strong acidophiles require high concentration of hydrogen ions for membrane stability. Acidophiles therefore have evolved a unique cell membrane structure. Here you see the structure of the cytoplasmic membrane and how different ion channels, you can say potassium pump secondary transporter, and composition of the cytoplasmic membrane are well managed and are highly stabilized through their different molecular mechanisms. And some biotechnological applications of acidophiles. Sulfolobus and acidophilus are thermophilic acidophilic archaebacteria as they grow temperature up to 90 degrees Celsius and at pH value of 1 to 5. Sulfolobus occurs in sulfur-rich acidic hot springs, while Acidinus is acidic sulfuric springs. Sulfolobus is aerobic, whereas Acidinus is facultative anaerobic. These two archaebacteria have the potential for applying or applied use in the recovery of metals from the ores through the process of microbial leaching. The microbes readily adapt to the conditions of low pH and high concentration of metals required for microbial leaching. In addition, these archaebacteria can survive at high temperature, which can occur during oxidation of metal sulfides in bioleaching reactors. Sulfolobus and acidophilus can also enhance the recovery of gold by oxidation of pyrite, which includes gold preventing recovery by standard metallurgical procedures. The ability of this group of microorganisms to facilitate metals recovery is yet to be developed on a commercial scale. Thank you. This is a very short presentation, and due to the time constant of this e-content development, so many things to be discussed with more elaborately, but for the time being and the evaluated process, I am concluding my e-content development presentation here. Thank you.